Okay, so we have people coming in. Hello, everyone. Good evening, and welcome to the first of its LGP Lodha Genius Program Thoughtlab series. Let's wait for a couple of minutes so that everybody can join in and be a part of this right from the beginning. So we will start exactly at 8:02. Yeah, just give a minute. Yeah, I think we can start. We are over 50 now, so let's start now. Good evening, everyone, and welcome to the Lodha Genius Program Thought Lab series. I'm Ambika. I'm the program lead for the Lodha Genius Program. It's just to say what Lodha Genius Program is. It's a program for high schoolers, that is 9 to 12 students, who are interested in knowing more about mathematics and science, not through a summer, starts with a summer, and then you are continuously engaged with us for over a period of 5 to 6 months. So this will be at Ashoka University. So this is actually an offshoot of the program where we bring in quality science in front of you and conversations, which is a rarity for many of you. So we bring it to your homes, and that's how the Thought Lab was launched. So we are very glad to have two very important people today here to have this wonderful conversation today with all of you. And I would also urge you to ask questions because we want to keep it as interactive as possible. So please raise your hand if you have a question after 20 minutes when we say the question answer floor is open, or else post your question in the Q&A box. I'm just stressing on the point on the Q&A box so that it's easy for us to read the question and answer them. Right. So with that, I would like to introduce to you Professor K. VijayRaghavan, who's very familiar to most of you, who's the chair of the Science Advisory Council of Ashoka and was also the former principal scientific advisor to the government of India. So, so glad to have you, Vijay, over here. And I let you take over from now. Thank you.
Thank you very much, Ambika. And before I start, I'd like to thank Ambika and the team and the sponsors of the Lodha Genius Program for allowing this to happen, and Ambika for reaching out to Dame Jocelyn Bell Burnell and getting her as the first person in this program. So good evening, everyone. It's my pleasure to introduce our distinguished guest for today's webinar, Dame Jocelyn Bell Burnell, Fellow of the Royal Society. Professor Bell Burnell is a renowned astrophysicist whose groundbreaking work has significantly shaped our understanding of the cosmos. She was born in Belfast, Northern Ireland, and she developed an early interest in astronomy inspired by her father's work at the Armagh Observatory. Dr. Bell Burnell's scientific journey began at the University of Glasgow, where she earned a bachelor's degree in physics, and then she pursued her doctoral studies at the University of Cambridge, where she made a discovery that would change the course of astrophysics forever. While working as a research assistant and reviewing data from a large radio telescope, she helped construct a detector she helped construct. Dr. Bell Burnell noticed a series of unusual, extremely regular radio pulses. This puzzling observation led to the discovery of pulsars, rapidly rotating neutron stars that emit beams of electromagnetic radiation. The significance of this discovery cannot be overstated. Pulsars have since become crucial tools in astrophysics, allowing scientists to test theories of gravity and providing insights into the nature of matter under extreme conditions. Throughout her career, Dr. Bell Burnell has held numerous prestigious positions. She has served as the president of the Royal Astronomical Society, the Institute of Physics, and the Royal Society of Edinburgh. She's been a visiting professor at multiple universities, and her contributions to science have been recognized with numerous awards and honors. In 2018, she received the Special Breakthrough Prize in Fundamental Physics, and in a remarkable act of generosity, she donated the entire $3 million to establish a fund for supporting underrepresented groups in physics research. Dr. Bell Burnell's legacy extends beyond her scientific achievements. She has been a tireless advocate for women and minorities in science, paving the way for greater diversity in the field. Her perseverance in the face of challenges and her commitment to scientific inquiry serve as an inspiration to scientists and students around the world. Ladies and gentlemen, please join me in welcoming a true pioneer of astrophysics, a dedicated educator, and an inspiring role model, Dame Jocelyn Bell Burnell. Welcome, Professor Bell Burnell. Let me kick this off by trying to see how we can segue from your early scientific discoveries to the importance of that in current astronomy and astrophysics, and then we'll move on to how we can enhance the role of women and minorities in this kind of research in particular. So to start, what inspired you to pursue astrophysics? And can you tell us a bit about the importance of serendipity in scientific discoveries, and what implications today do your early discoveries have?
Well, let me start with the first of those questions. I was a graduate student in Cambridge, England, a very overawed graduate student. There were very few women in the place. There seemed to be a lot of young men who were apparently very clever, and I was not sure I was clever enough. I thought maybe they'd made a mistake admitting me. They would discover their mistake and they would throw me out. So my policy was to work as hard as I could, do the best work I could until they threw me out. And then at least I'd know I'd done my best. So I was working very hard. In the end, they didn't throw me out. I had my full 3 years in Cambridge as a student working for my doctorate. And because I was being very thorough, very careful, I was following up on all sorts of anomalies in the data. And one of these anomalies turned out to be the pulsars.
That's pretty amazing. And did that require a substantial amount of dedicated work, looking at all the data carefully over hours and hours? Or was there something staring at you in the face?
The PhD program in Britain is a 3-year program, and I spent the first 2 years to build the radio telescope. Quite a lot of this was manual labor. At one point, I was swinging a sledgehammer. I was also playing hockey. You know about hockey in India, field hockey. I became so strong I could hit the hockey ball from one end of the pitch to the other.
Lovely.
So there wasn't much science in that, but there was a lot of labor, of hard work.
Yeah.
And then after 2 years, the telescope was built, and it was my job to run it and analyze the data. And the data came out on rolls of paper chart, kilometers of it. You did nothing but look at this wretched chart. And I'm still feeling I'm not bright enough to be in Cambridge. They've made a mistake admitting me. They're going to throw me out. Incidentally, this has a name. It's called imposter syndrome. So I'm being very thorough when I'm analyzing these charts. And I get to recognize the quasars, which is what I was meant to be studying. I get to recognize radio interference, because if you have a very big radio telescope, you pick up all sorts of radio signals that you don't want. But there was just in one little patch a signal that I couldn't explain. And that's what turned out to be the first pulsar ultimately. So it was through being pathetically thorough.
Absolutely. So it wasn't good, it wasn't serendipity, it was thoroughness which allowed you to detect something which most others would have missed.
I think it was largely thoroughness. Yes, indeed. Yeah.
That's really good to know. Jocelyn, if I may jump and to a more recent time when you were given the Breakthrough Prize, and you donated that to establish the Bell Burnell Graduate Scholarship Fund. What kind of impact has it had since you established it, and what do you think it will have going forward in the future?
It's established especially to fund people from groups, populations that are underrepresented in physics. Physics in Britain is full of white men. So
Even
anything other than white men. It's, because I believe that a diverse group is more successful than, shall we say, a monochromatic group.
Yeah, yeah.
And I was keen to increase diversity in physics. So our Institute of Physics run this program. I gave the money to them and they run it. And each year they've been funding perhaps about 12 new graduate students. A lot of them are women because women are underrepresented, but also people of color are underrepresented. Disabled people are underrepresented. So it's people from those groups that they're particularly looking at and hoping to find some very bright ones who could do a doctorate in physics.
Yeah, wonderful. This is really very nice. You know, Jocelyn, if you look around large astronomy ventures all over the world, there are telescopes in Chile, in Hawaii, in India, but also new ones coming up in South Africa, the Square Kilometer Array. Now, in some ways, given the love for big data and its analysis today, and the career opportunities after that, is this an opportunity for bright young Africans, women in particular, to join in this enterprise? Do you think that's happening? Or since that Square Kilometer Array is at its early stages, how can one make it happen?
It is happening. It needs to build up more, but that will come with time. So I think it's important for young people in Africa, particularly those who can do physics.
Right. So, in that context, generally, the leadership of these large ventures is by people who have been there for a long time, almost by definition, or at least at mid-career people. And again, almost because of the history, it's very likely that these are going to be men from the West. And now, how does one stimulate women coming to leadership position? Do you just take bright young women and assume that they will be, taking on such positions, or do we wait for them over decades to come up?
A certain amount of it has to be waiting, because you must not appoint underqualified people to these positions. They will be unable to do the job. They maybe be sacked, and it's bad for the reputation of the new facility. So you do need to have people with a certain amount of experience. But the number of women in leadership roles in physics and astronomy is growing all the time. I'd say it's still a minority, but it's growing.
And what do you think are the challenges that remain now in the top centers, and also the challenges to grow astronomy in new emerging science countries such as China and India, and have representatives of women there?
Yeah, there are still things that we haven't really sorted out. It's the women who have the babies, and look after the babies when they're very small. So their careers are more broken compared with a man's career. And when people are making appointments in later years, they need to be aware of this, that the woman may have a more disjointed career. There are also issues with what we call the two-body problem. If you, a male scientist and a female scientist marry, can you get good jobs for both of them in the same place? There are things like this that we haven't really sorted out.
And traditionally, men seem, for again, historical reasons and social practices nowadays, or in the past particularly, men network much more easily, they find mentors much more easily, and women have great difficulty or greater difficulty in doing so. So what role do you see mentorship has for the growth in number of women in science and in leadership positions, and what can we do about that?
Well, everybody should have access to mentorship. It's improving, but more needed.
Right. And lastly, before we go on to the questions, based on your experience, what advice would you give to young female scientists facing barriers or discrimination in their careers? Because the tendency would be, if these barriers are high or the discrimination is strong, is to just drop out and do other things. And science is a lot of hard work, a lot of it is not rewarding. And if in addition there are socially constructed barriers, it's a big challenge.
Well, heads of organizations, heads of laboratories should be monitoring the progress of the young men and the young women in their laboratory. And if they see that the young women are not progressing as fast, they need to say why, ask why, and do something about it. It's not something that the young women themselves can solve. It's up to the leaders of laboratories.
And do the astronomy societies in Britain, for example, and in America, do they proactively have programs for mentorship in general and for women in particular? Or is that an organic growth which takes place?
I think it's more likely to happen at a more local level, to be honest.
Right. Lovely. Thank you very, very much. And now, Ambika, is it okay? Can we open up for questions?
Yeah, we can. So because it takes some time for them to type or ask.
Yeah.
So I can put the announcement here. Maybe we can do one short conversation before they ask.
Yeah.
But then I'm just going to ask them, please type in your questions in the Q&A box or raise your hand. Raising your hand would be easiest so that you don't have to type. But if you're feeling shy, then please do put your questions in the Q&A box so that we can take it through. Okay, the whole idea is to engage with the panelist, so that
And
it's not a...
maybe I can ask one question, Jocelyn, about your early schooling. How did you stay on in science? Did you have early setbacks? Did you? I heard that you moved your school and then went into science after that. And early on, science didn't. Or your school, you didn't do well in your school, but you moved on, persevered, and did well. Is that correct?
The school I was at, this is in the north of Ireland, expected the girls to do needlework and cookery and the boys to do science. And that's how they separated us. And when I discovered what was going on, I said to the cookery teacher, I think I should be in the science class. She said, no. But when I told my parents that evening, they hit the roof and they phoned up the head teacher and said, we want our daughter to do science. The local medical doctor also had a daughter in the same class, and he said the same thing, and so did another set of parents. So by the second time the science class met, there were 3 girls and all the boys. And very fortunately, I came top in the exam at the end of that term, the science exam, so showed that girls could do science, and the school really could not prevent us from doing science after that.
Lovely, lovely. Yeah, that's really amazing. Yeah.
Okay, we have questions coming in now. So please do put in more questions. We have over 80 participants, so definitely more questions. So first question is, how will astrophysics change the course of history in the later future?
I'm not sure that astrophysics will change the course of history. People who get to do astrophysics usually enjoy it very much, learn a lot, and it makes you realize that we are small things in a big universe. And perhaps it's no harm that we are reminded occasionally that we are small things. So that's, I think, probably the best way to answer that question.
Right. Okay, there you have the answer. I didn't have a name for the person, so I couldn't read out the name. So now Shreya Sareen is asking, what particularly drew you to physics among all the science fields?
Sorry, there was a bit of interference in the middle of that question. Could you say it again?
Yeah, sure. What particularly drew you to astrophysics among all the science fields?
Right. Well, when we started doing science, the first thing was physics. We did chemistry in the second term and biology in the third term. And one of the things we were learning in physics was about motion in a circle, centrifugal force and centripetal force. And at the same time, I have borrowed my father's library book, which is an astronomy book by somebody called Fred Hoyle. And he's writing about these big galaxies that rotate. And I can see that the physics I'm learning at school about centrifugal force and centripetal force will apply to these big rotating galaxies. And since I like physics, I think, right, I could do astrophysics after school.
And Jocelyn, your father also was involved in building the local planetarium, wasn't he?
He was the architect for the planetarium, yes. Not actually building it, but he had to go visit the site quite frequently. And with that one, very frequently, because the builders had real problems getting the curved roof to fit together and be weathertight.
No, I think that's how you start seeing science in your everyday life, and then you get so much absorbed and inspired. So I guess that's the answer to that. And now moving on to stereotypes against women in STEM fields. So do you think there is a large bias against any show of femininity within physics? I've noticed that women who are involved in physics are also expected to not participate in traditionally feminine activities, even just dressing up and looking nice. Is there a pressure to act masculine to be taken seriously in STEM fields? The question comes from Mehek Nakwi.
That's a very, very interesting question. I don't think you're expected to act masculine, but equally, it's not a good idea to wear dresses that are too sexy, because that complicates life in the laboratory. So keep sex out of the laboratory, I'd say.
Okay. Very interesting. So Lippy Tukrel says, very interesting conversation regarding organic growth of women in leadership roles, especially in mid-career section. Is there any particular advice you have that can help expand their scope? Networking is one of them that may help. Any other aspects that you would recommend?
Yeah, I'd put networking top of the list, because women in leadership positions are usually a bit lonely, a bit isolated. There won't be many other women around in leadership positions. So if you have a group of people you can talk to, you know what happened in the office today? Somebody said whatever, and I thought that was quite wrong. What do you think? You know, having a chance to talk with other women who maybe have similar experience. I think is really rather important, while women are in a small minority. It's quite hard to organize though, but if you can, it's worth keeping that relationship going.
Right. Okay, there's one interesting question from Navya Agarwal. Hi, Navya Agarwal here. Girls often find themselves alone in pursuing sciences and they have to team up with boys for projects. But boys then team up amongst themselves. Any suggestions on how to manage in such situations?
If you're in a classroom, the teacher should be doing some of the teaming up, make the teams, and not just keep the same teams forever, change the teams around every few weeks is also important.
Yeah,
But that should be a teacher's job.
good point.
Good point. Good point. I think there's a very interesting question. I think this is also for people who are not much into sciences and also in other fields. Yashin asked the question, what is the point of pursuing a career in pure science if it has no application in our daily lives, given that we know already about a relatively small position in the universe? What is the point of our discoveries? I really want to know. I do not ask this cynically.
Mm-hmm. No, of course it's not cynical, and it's a very good question. It's important that we keep learning more about our environment, the universe, the way things work, because we need more clever devices and things in the future, for example. And of course, we need things that I can't envisage and you can't envisage in the future. So increasing our stock of basic knowledge is very, very important. Some people are really good at that. Other people are better at the application side. Don't expect everybody to be good at everything. You'll be most successful if you focus on the bit where you're most successful.
Yes, I think that might be a question which many have. So we'll take a question. Somebody has raised their hand. So I'm just going to allow Osman Qureshi to talk. Osman, can you unmute yourself and ask the question? And tell where you are from, whether you're a student, which class you are in, etc.
Hi, I am Usman Qureshi, and I'm a a grade 10 student now. I'm from Kashmir, and I had a question. Did you have any mentors during your school? And if you did have them, how did they help and influence?
Thank you. Mentors are important, but for quite a lot of my life, I was the only female. And I think the senior men were a bit uncertain about mentoring a woman. So I had really very little mentoring. I was lucky in Cambridge in that I lived in a women's college. And while there were not other women doing physics, there were other women doing other kinds of science. And over dinner at night, we could talk about what had happened during the day. And they could sometimes offer some very good advice. We were all in rather similar positions, even if mine was more acute than, for instance, women in biology.
Okay. Okay, so let's move to Mosham Sarma. Can you unmute yourself and ask the question, please?
Yes, ma'am. Am I audible?
Yes, very well.
Okay, greetings, ma'am, and everyone present here. So basically, I had a bit of specific question on ma'am's specialty, that is pulsars.
Mosham, if I may interrupt, can you just tell me your grade and where you're from?
Sure, ma'am. So I'm studying in grade 8 in St. Vivekananda English Academy, and I'm from Assam, Guwahati. So basically, my question is a bit more specific on ma'am's subject, that is pulsars. So basically, as per my knowledge, pulsars are basically super fast rotating stars that release electromagnetic radiation, and these are like emitted from neutron stars, which like after a supernova explosion of a star, these neutron stars are formed. What happens is that I want to ask that do this pulsar array affect our solar system in any positive or negative way, or is their effect on our solar system neutral? Because as per my knowledge, the closest neutron star is around 300 to 400 light years away. So
Yeah.
having an effect, according to my preconceived notion, is that these electromagnetic radiations or this star don't pulsar rays, they don't have much effect on our like solar system. So according to this hypothesis of mine, these pulsars won't have like a much effective relevance in our space interest. So what's ma'am's opinion on this?
Yes, I think you're right. The pulsars, like many astronomical objects, are at a big distance from the Earth, and they don't have a direct effect. Sorry, let me get my thoughts together properly. They will be useful when the time comes that we have spaceships and we go traveling through the galaxy in spaceships, because they'll be good as navigation beacons or lighthouses. But for the time being, they don't have much effect on most of us and no effect on the Earth. Physicists like them very much, professional physicists, because they can already use them to test some bits of relativity theory. And that's work that's going on all the time.
Sorry, let's move to the other question by Johan Philip. Johan, can you unmute yourself? Yeah.
Hello, ma'am. My name is Johan. I'm studying in grade 8. I'm from Kerala in India. So I would just like to ask you a question about what do you think is interesting and should be explored in the field of astrophysics today in general? I mean, Europa Clipper launched a few months ago. Its stated aim is to search for life on Europa. So, that's more of a local thing, but what do you think is like the main priority for what we should focus on in astrophysics? Should we focus more on like local, perhaps stuff that's in our solar system? Should we focus on exoplanets? Should we focus on strange astrophysical phenomena? I suppose you might be a bit like biased considering you've been working on pulsars all your life, like, for a lot of your life, but I would just like to know your honest opinion on what should be focused on in the future.
I think the most exciting thing at the moment is a whole new spectrum of what's called gravitational radiation, sometimes less accurately called gravity waves. If we have a pair of stars orbiting each other, the stars make a hollow in space-time, and as the stars orbit, this hollow goes round, and then there are waves in space-time that go out into space, and they produce a kind of radiation called gravitational radiation. This is totally different from the spectrum we've learned about. It's nothing to do with light and radio and infrared and ultraviolet and all that. It's a whole new spectrum. And to be around when a whole new spectrum opens up is utterly amazing. It happens about once every 500 years, probably. So if you're interested in a very new area of physics and astrophysics opening up, try and find some reading material about gravitational waves. Sometimes they're given the slang title gravity waves. Actually, it's gravitational waves or gravitational radiation. And that's where the real new stuff in astrophysics is at the moment.
If I may interrupt here, Jocelyn, the Laser Interferometric Gravitational Observatory has 2 sites in America, and a third one is coming up in India.
Yes.
So for bright young students here, there's a great opportunity.
What's the name of the Indian site?
It's in Maharashtra, near Nasik. The specific location just escapes me, but it's the third LIGO site.
Yeah, it'll be very important.
Yeah.
In astronomy, if you're studying something, to have 3 separate telescopes all studying something, it helps you get a good angle, a good position on it. So
Right,
it
right.
will be very important. The main,
Abhigyan,
sorry,
so
carry on.
Vijay just messaged that it's at Hingoli near in Maharashtra.
Right, good. So maybe you get a summer job there. That would be good.
Why
Absolutely.
don't you come for the program and then we can get you a summer job there? No, I mean, it's interesting, Jocelyn, that the first question was from a student who was in Kashmir, and the current question was from somebody in Kerala. The distance between these 2 points is more than
Yes.
3,200 kilometers.
Yes.
So it's amazing that we have people from all over asking questions, and a lot of questions coming up. Okay, we move to the next one. Arika Gowda. Can you please unmute yourself, tell your
Yeah.
class, your geographical
Hi.
location also?
Am I audible?
Yeah.
Okay. I'm Arika. I'm in class 10. I'm in Karnataka. And I would like to know whether you have experience in other fields of physics and whether you have any advice on more upcoming or niche fields in physics like quantum physics or quantum computing.
Right. I don't know much about the quantum area, Arika, but I'm sure there are developments there. My knowledge is really in astrophysics, astronomy, that kind of area. And in that area, we've already mentioned these gravitational wave detectors, which I think will be a very exciting development. And it's fantastic that India has is building one of the major sites for this telescope. It's really going to put Indian physics and Indian astrophysics on the world map in a very big way. So watch that field.
All right, so we'll try and now answer some questions from the Q&A box because there's so many questions which are piled up. Okay, so so how do you recommend simplifying complex physics concepts for better understanding?
Some people can do that. Some people just don't seem to be able to do it. If you're good at it, great, please do it, because you'll help other people understand more, and you'll show that physics is not necessarily totally opaque and incomprehensible and all those other negative images that physics sometimes has.
I have a very interesting question here. Somebody is pleading me to ask a question on the Joy Division album that used your pulsar readings for their album cover. What do you have to say about that, and how did that happen?
The actual images were from a United States observatory, one that I think is no longer functioning, if I remember rightly. And the designer of the cover saw these images and thought, oh, they'd look good on the cover. It is, in fact, pulsar data. It's the shape of about 10 or 20 pulses. So he took a run of 10 or 20 pulses and just plotted the shape of each of them. And the shape's not strictly constant. It does fluctuate a bit. And so there's interesting pattern it makes because they're not quite identical. Yeah, it's a very famous cover.
Yes, I think that person was going on asking me in the thing because we were not taking those questions. So anyway, so that's answered. So there is a question from Abhigyan Ray. So I would request all of you to put questions in Q&A box because it's a bit difficult for me to scroll through. How do you deal with pressure, deal with strong or wrong expectations from family? Teachers, yourself.
Yeah, I didn't actually have problems with my family. It was with the rest of society. Most people thought girls couldn't do physics. And in my particular generation, they wanted a lot of girls to do things like needlework and cookery and so on. But my parents were very supportive. They said, if that's what you're good at, that's what you should do. And it's a waste of the talents you've been given if you're not able to study those areas. So Yeah, particularly I think it's an issue more for women than for men, for young women than young men, because
Right.
we're often expected to get married and follow our young man, follow our man wherever he goes. But increasingly in Europe, in Britain, more and more women are working. That particular image of the woman following the man works if the woman is a stay-at-home wife who does not work, who does not have a job, who does not have a career. But in Britain now, women expect to have careers as well as men. Very few of them want to be stay-at-home wives and mothers.
Right. Okay, so we have a question from Arushi Verma. Where do you think we stand in today's age and time in terms of parity in publishing? This question might be a bit contentious, but do you think, oh my God, Mama, do you think that there should be some reservation in science prizes for underrepresented groups to acknowledge their lived experiences and difficulties and to promote their research?
Yeah. I think we do not, in Britain, we do not deal well with that issue. Underrepresented groups have it tougher, harder, I'm afraid. And that's partly why I gave money to the Institute of Physics, so that people from those groups could study for PhDs. I think everybody needs to keep saying that diversity is important. If you have a laboratory full of, let's say, young men, all from Kashmir, just to take an example, that laboratory will not be, in the long run, as successful as a laboratory that contains young men and young women, and that they come from all over the country and all sorts of backgrounds. You need a diverse workforce to be really creative. If your workforce is too monochromatic, to use a physics term, they probably all think alike, and that will not be as productive as a group that has more diverse people who say, hey, what about? And introduce a totally new idea or concept. Diversity really matters. And in Britain, our problem is we don't have enough women in physics. And that's why I set up the program that was mentioned in the introduction, to allow young women to do PhDs in physics.
Right. So in connection with that, what steps can be taken to create a more inclusive and equitable environment for women in astrophysics or STEM in general?
Yeah. One of the things you can do is monitor the data. Well, collect the data and monitor the data. How many young women are there? How many young men? Who's getting more funding? How are they progressing? Are they being promoted or not? And if you do that in Britain, you find that in physics, the men tend to advance faster than the women because the environment is mostly male. So monitoring the data, maybe one woman is just not so clever and that's why she's falling behind. But if all the young women are falling behind the young men, there are issues in that department, in that laboratory, that need attending to.
Right, right. No, I think it's very valid. And Vijay, do you want something to add to that in comparison with what's going on in India?
So my question is, has the composition of graduate students and professors changed in physics departments across Britain in the last, say, 2 or 3 decades?
Yes, it has, gradually, not that fast, but it has undoubtedly. There are definitely more women, and particularly in astrophysics, there are a lot of women now, probably still in a minority, but only just in a minority.
That's interesting, because in biology, the numbers of women have shot up dramatically all over the world, and of course in Britain.
Yes, yeah. It's changing.
Moving on to the next question from Hia Atreya. hello, you had mentioned that you had imposter syndrome when you were at Cambridge. How did you turn that into something that empowered you as opposed to bringing you down, especially if from time to time you didn't do as well as the rest of the class?
Yeah. Well, I knew I only had 3 years. That was my funding. And if at the end of the 3 years I had not written a thesis, I would be in big trouble. So it's an important opportunity, but it's a very limited opportunity. And once you recognize that, that helps you be a bit tougher and saying, I am going to do this. I know so-and-so thinks I can't do it, but I know I can, and I will show them. And maybe along the way, you accidentally discover pulsars as well, something like that, because you're working very carefully and very thoroughly.
Yes, that's very valid. I think that's a good attitude to have if you're listening to it. So the next thing is interesting. So Mosham Sarma has asked again, while you emphasized on diversity, don't you think DEI candidates, that's diversity, equity, and inclusion, candidates in fields from administration to sciences, undermine pure talents and give special attention to DEI candidates instead of the real impact bringers, let it be if they are from privileged backgrounds?
Disabled people still have brains, and often their brains are better than some of able people. Think of people like Stephen Hawking, brilliant brain, but a man almost helpless in a wheelchair. So it's not obvious who has good brains and who has not until you all start doing research. Then it becomes a bit clearer. And it's nothing to do with gender, and it's nothing to do with disability, and it's nothing to do with what part of the country you come from.
Very well said.
Okay, so next question is about, do you think the historical biases and stereotypes are still affecting the contributions of women in STEM?
The stereotypes in Britain are still there, yes. I can't speak for other countries because I don't know them so well. But in Britain, yes, there remains a bit. And that's one of the reasons I try and do many outside talks and events like this, to show that there are women doing science, doing physics, can do it and enjoy it.
Yeah, absolutely. There is a question, I think it's a very practical question from Navika Sagal. I'm in class 8 and how can I build networking in this stream?
Right.
I think that's something a lot of students do not know. Yeah.
Could you tell me what age of person is class 8?
13 years.
Right. Okay. Right. So some more years of high school yet ahead of them.
Yes. The start of the high school, actually.
Yes. Yeah. High school can be difficult because there may not be other people like you with the same interests. Or there might be, and they're in different years. They're older than you or younger than you. I don't know if high schools in your country ever have clubs, societies. Whether maybe you could try to have an astronomy club that meets after school once every month, every 2 weeks, to talk about astronomy and what new stuff people have heard. It's very good for people to mix with students from other years. So that's quite helpful to everybody. And if you've taken the initiative to create this, that is something that you can put on your resume, what we call a curriculum vitae. I started an astronomy club at my school. Yay, good.
Okay. So next question is about, I think we've sort of answered this, but I think that a lot of people asking the same question about how can astrophysics and such scientific stuff contribute to the welfare of people and economic growth in developing nations?
No. Well, Astronomers are forever trying to see faint objects way, way out in space. And so we develop equipment that's good at picking up faint amounts of light and so on. And that kind of equipment can be useful in other places, in dark environments, maybe in mines or in caves where you need light made artificially. So there are all sorts of spin-offs. And I don't think you should censure any bit of physics simply because it does not obviously have some spin out, something that's of use in society today. It may well be of use in society in a generation or two. I think it's important to do research in all kinds of areas without worrying too much about immediate applications.
Right. Okay. So next question is about geopolitical tensions from Kostav Puzari. How does geopolitical tensions impact setting up of infrastructure to facilitate research in your field?
Geopolitics doesn't come into it too much. There has been an issue with the Soviet Union recently, which has meant that things there are, collaborations there are more difficult. And anywhere where there is war, things like that, you know, like Israel, Lebanon, Jordan, Syria, just to mention a few, it's, you know, under those circumstances, it's quite hard to do academic research at all, probably impossible. But for the rest of the world, research is important. Some of it's very specific, but it's also important to do research that does not obviously have a benefit, because in the longer run, there probably will be. So we need to do research across a whole range of topics. Some of them will come good next year. Some of them will come good in 20 years' time.
Vijay, do you have something to add on to it from an Indian context?
Well, you know, India, Jocelyn, is one of the contributors to the 30-meter telescope, which is coming up in Mauna Kea in Hawaii. And that ran into a lot of pushback from traditional communities there about building the telescope. And after a lot of discussion, that was finally resolved. So that's an example of how, you know, a science endeavor can run into complexities if you don't take into account local context. And now the local communities are part of the management of the telescope. So that was resolved in a nice way.
So even in the case of LIGO and setting up of it, so you see there's a lot of
setting up of LIGO again, you know, this was done with a lot of collaboration between the US National Science Foundation and India. And many of the questions here are about, is it worth it for India to go into such a heavy investment in fundamental research? And ultimately what swung it was the point Jocelyn made so nicely, that all the technology, the vacuum technology, the laser technology, have applications in industry. And with Indian industry working on this, it will catapult them into deep tech area, which otherwise they wouldn't have been able to do.
Yeah. All right. So there is again a more practical question. Do you think talent is more important than passion in science, or do you think it's the other way around?
Oh dear. That's not something I've thought about much. I think what's really important is that people do good work and don't fuss about status. Do your best work, and with luck, the status question will resolve itself.
Yeah, I think it's a very difficult thing to practice, though, for many people, but it's a valid point. So, okay, we have somebody raising hand. That is Trishanjit Paul. Trishanjit, can you ask your question? Tell them where you are from and your grade if you're a student. Trishanjit?
He's
Are you
muted.
there? Yeah, you're on mute, okay? We can't hear you. I still can't hear him. Okay, all right. So we move to the question then. I'm just going to put him off. What is your opinion on the theory of the multiverse? Is it plausible?
It's, it may be plausible. It's very hard to get evidence for or against, at least at the moment. It's an idea that's worth keeping hold of, because you may suddenly realize, oh, I could check this out the following way because we've developed something new. So not to reject the idea outright, but to say at the moment, don't know, can't tell, can't answer the question.
Okay. Do you have any suggestions on courses or internships that could give us experience and detailed information in physics in class 10? It's very specific.
Oh dear. I don't know the Indian situation well enough to be able to advise. Maybe Vijay and you have better answers than I do.
Vijay, do you want to?
Well, you know, there are increasing opportunities for summer and winter internships. By the way, there's a huge new planetarium coming up in Mysore, which will be ready in 6 months' time. And that's an interactive one, which also has a technology park where you can build and play around with optics and lasers and so on. So ranging from that to the Indian Institute of Astrophysics and its telescopes all over India, there are extraordinary opportunities for internships in India. And of course, the Lodha Genius program supports people for these internships in India and abroad. So the opportunities are really increasing a lot.
Yeah. So
Absolutely.
inserting the program promotions, that the applications are open. So you can just go to the website and click on it. And you will have networking and internship.
And Jocelyn, it's a fully supported program. The students don't pay.
Great.
Yeah. So there's a question for Vijay. It's
Oh my
specifically
God.
written there. Yeah. It's a bit controversial, but it's about your geopolitical answer. How does government prioritize research in times of political strife?
You know, this is a webinar where Jocelyn is supposed to answer the questions, but I'll answer this. What I'm absolutely stunned by is how the government has been supportive of big astronomy projects over years. And it's much more difficult in other areas to get support. So, for example, India is supporting the 30-meter telescope, the LIGO, the square kilometer array, other telescopes all over the world in high energy physics. India is a contributing member to CERN. So it's somehow the understanding of universe origins and how it works is something which captivates everyone so readily. It's pretty amazing. You know, when I was temporarily secretary in the Department of Science and Technology, the 30-meter telescope came up for approval. And I assumed, like biology projects, the finance ministry will push back hugely. But exactly the opposite happened. The external affairs ministry and the finance ministry were wildly enthusiastic. So for some, astronomy is exciting and captivates people's minds. And we should use that.
And it's a very good way of teaching physics.
Absolutely.
Yes. Okay, so I think one final question we'll take from here, because we have just 1 minute to close, and we have 49 questions unanswered. So, okay. In your view, yes, I mean, it's a good sign, but you can keep asking us, you can mail us what your questions are. We'll try and answer that. So, in your view, how much of scientific discovery is driven by chance and how much by actual planning and persistence? Also, how do you think advancements like quantum computing, for example, would change how we do astronomy research in the next few years? Okay, two different kind of questions.
Yeah. I'd say in the first half, it's about 50-50 chance and planning. I think quantum computing is going to be very important because we're dealing with much, much bigger quantities of data, information than we used to. And so we do need faster data analysis. But we also need clever people to make sure the computers ask sensible, even clever questions of the data.
Great. So I think we are almost out of time. And Vijay, I know there were a lot of questions asked. And if you're looking for a webinar for the program, we're doing it on 28th December at 11 a.m. for an hour. So please do that. Go to our YouTube and visit all the previous webinars before you come for that. So Vijay, for the closure.
Thank you very, very much, Jocelyn. It's an inspirational and learning experience. And I was really impressed. You know, all these questions came from students in what you would call this first or second or third form, you know, 8th, 9th, and 10th class students, most of them. And it's absolutely, and some senior ones too. But it's really been really terrific to have you kick off this series. And it's a very high bar now, and we'll be hard pressed to find the next speaker of this quality. Thank you very, very much.
Thank you for the opportunity. It's been fun for me.
Thank
Yes,
you.
and do you have something to say to the students who are asking so many questions to you, actually?
I'd say to the students, good luck and work hard.
Yes.
Yeah.
I think that's the most
Thank
important
you.
advice you can get.
Absolutely.
Thank you. Thank you so much, and have a very good evening, Jocelyn and Vijay.
Thank you all very much. Thank you.
Bye-bye.
Bye-bye.
Bye. Thanks,
Bye-bye.
everyone. Thank you
Bye.
for being there. Bye.